So we're going to be going over the second derivative test. Okay, so we've been doing the first derivative test. The first derivative test is a way of finding where a function is increasing or decreasing, or finding our relative maximums and minimums, or if they are neither. The second derivative test tells us our points of inflection and our concavity of the graph. Okay, they're the exact same format. The only difference is they tell us different information. So since we're doing a second derivative test, since we're testing the second derivative, that's the first thing we need to do. We need to find our second derivative. So we start by finding our first derivative. So we get negative 3x squared plus 12x minus 9. That's our first derivative. Then we scoot right through that to our second derivative, and we get negative 6x plus 12. So that is our second derivative. So now that we have that, we're going to do our second derivative test. To do a second derivative test, just like the first derivative test, you start by setting it equal to 0 and finding your zeros. So when we set it equal to 0, we move the negative 6 over, we get 6x equals 12, which means x equals 2. So that 2 is our critical point of our second derivative. That means that that could be a point of inflection. Now, the next thing we do is we create our number line. So just like a first derivative test, we put down our zeros. So 2 is a 0 of our second derivative. And we are now going to test our second derivative. Since it's a second derivative test, we are going to plug these values into our second derivative, hence the name second derivative test. So we plug in 0. When we plug in 0, we get positive 12. Then we're going to plug in 3. When we plug in 3, we get negative 18 plus 12, which is negative. So on one side of 2, my second derivative is positive. On the other side of 2, it's negative. Well, that's telling us our concavity. When the second derivative is positive, that means our function is concave up, like that. When our second derivative is negative, that means our function is concave down, or it cups down. Okay, like that. Now notice that we draw our symbols on our test differently than we do our first derivative. On our first derivative, we would show our horizontal tangent at the 0, and then our curve would be at the 0. For the second derivative test, our curve is on either side, because this is where my function is concave up, this is where my function is concave down, this is where it is neither concave up or concave down. That's where it changes concavity. That is what we call a point of inflection. So our point of inflection is at 2. But on the left side, it's concave up, and on the right side, it's concave down. So since it's asking us to write our intervals, our function is concave up on the interval from negative infinity to 2. So everywhere it's concave up. It's concave down from 2 to positive infinity. Okay, so it's just like if I asked you to find where the function is increasing or decreasing, you do a first derivative test, and then you'd give me the intervals where the function is increasing or decreasing. This is the exact same thing, except with concavity. So we're finding where the second derivative and using it to find the intervals where it's concave up and concave down. Okay, all right. Determine the points of inflection and find the open intervals which the graph is concave up or concave down. Basically, we're doing the exact same thing we did on the last problem. The only difference is they're asking us to determine if they are in fact points of inflection and where they are. Okay, so again, just like the last problem, the first thing I need to do is find the second derivative. Okay, so we got to go through the first derivative first. So 3x squared minus 12x plus 12, that's our first derivative. Then we go straight through to our second derivative. So we get 6x minus 12. Set it equal to 0. That means x is 2. So that's our possible point of inflection. So again, to figure out if it's a point of inflection or not, we set up our number line, do the exact same thing we did at the last one. So I'm going to plug in 0. When I plug in 0, I get negative 12. So on this side, my second derivative is negative. Then plug in 3. When I plug in 3, I get positive. So on this side, my second derivative is positive. And again, how does that relate to our original function? Well, again, this is telling us our concavity. So on the left side, it's negative, which means concave down, or it cups down. On the right side, it's concave up, or it cups up. That means since it does change from negative to positive, our concavity, 2 is in fact a point of inflection. So I always write it as POI, or point of inflection, with a capital P, capital I with a lowercase o. And our point of inflection is at 2, and since we need our y value, we find g at 2. And when you plug it in, you get 8 minus 24 plus 24, so 2, 8. That is our point of inflection at 2, 8. And again, it also asks us to do our concavity. So it is concave up from 2 to infinity, and concave down from negative infinity to 2. So you can see, basically, the second derivative test is identical to the first derivative test in structure, method, and practice. Okay, the only difference is it tells us different information about our original function, where the first derivative gives us increasing, decreasing, and critical points, maximums and minimums. The second derivative gives us concavity and points of inflection.